Good morning. This is Deekshitha Gaddam from Capstone Group Project 65. We are here to present a project, Fitsup, Water Quality Monitoring System. The main aim of a project is to monitor the quality of water using some basic parameters like pH, temperature, turbidity, and conductivity.
Morning everyone, this is Rohan Bansal from Capstone Project Group number 65.
Hello everyone, my name is Devaangini Mehta and I am from Electronics and Communication branch.
Hello everyone, my name is Shivam Sinha. I am from Electronics and Communication.
Greetings, professors. My name is Jaiesh Thapar, and I am from Electronics and Communication branch, and my capstone group is group number 65.
In software part, the tech stack is for backend we used Django or Python. For frontend we used Vue.js. For server we used Heroku, custom VPS. These are the codes which we used for the backend in order to update the data in the backend. The HTML codes and the Bootstrap codes are used for the front-end purpose for the outlook of the website. Now coming to the website part, as we click on the link, an authentication or the login page pops up in which only the authorized user can drop in the website. We have added authentication to our website. Here the username is Jayesh and password is password. Once we get in the website, there is a menu. You will find 3 sections in menu. As we go into the Fitsup dashboard, we have temperature sensor, turbidity sensor, pH sensor and conductivity sensor. As soon as the probes of the temperature sensor and the pH sensor gets into water, we get readings for every 2 to 3 seconds and update it via Node MCU to the server. This is what we have taken care of. Both of the readings we can see in the website as soon as the probe of each sensor gets into the sample. Coming to the turbidity and the conductivity sensors, they are hard-coded values because we don't have turbidity and the conductivity sensors attached yet to the hardware because of the budget constraints we had. We have both temperature sensor and pH sensors with us attached to the hardware, and they both are working perfectly fine. Now we are moving from Fitsup dashboard to historic entries. Here we show the readings, date and time when the server values are taken. The values of temperature are in degrees Celsius. As we scroll down, we can see when and what time we have taken the readings. We have both pH and temperature sensor readings as they are not hard-coded values. Like as you scroll down, we can see the pH readings as well. Now going to the quality checks. Here we tell the user if the water sample we tested is feasible for human consumption, agricultural use, factory use, bathing, medical use or not. If it displays pass, it means the water is feasible for that purpose, and if it displays fail, then it means the water is not feasible for that particular purpose. This is the software part.
Now, here comes the hardware part of our project. This is the Node MCU having an indicator LED, and there is a resistor which is connected to the LED. And this resistor is a pull down resistor which is used for the temperature sensor. And this is the module which converts the resistance of pH sensor into the analog. The analog power and the ground are connected to the node MCU. Coming to the node MCU, D1, D2 pins of the node MCU are used to control the LED to flash red, green and blue colors accordingly. D3 pin, that is the 4th pin of the node MCU, is connected to the temperature sensor. Temperature sensor directly sends the signal in the digital form. Generally, in digital communication, we have one ground as reference and it is 2 wire communication. But here, it's 1 wire communication, that is single wire is used to send the data stream in data in the bits. The temperature readings from the temperature sensor are sent to the pin D3 of the node MCU. In node MCU, we have only one analog pin. So if we have to add some more sensors, then we will have to use analog multiplexer. Here you can see we have soldered everything, and the reason we didn't use the breadboard is to get a better accuracy and to reduce the cost. Now here is the pH sensor. The pH sensor has a module attached to it. The probe of pH sensor is detachable. The module reads the value of pH sensor probe, and when you dip the pH sensor probe in the liquid, we get the pH value. Here, the blue one in the module represents the thermostat. If we are not getting an accurate value of pH, it can be controlled using the thermostat. This is the indicator LED in the node MCU. It flashes red when we are taking the readings. It double flashes blue when the server gets the reading. And if in any case it doesn't flash blue, then that means the internet is not connected or there is some error. This is the code that we used and uploaded in the Arduino, and this will help us in getting the values measured by the different sensors.